So Felix is a student at Stuttgart, and you can introduce yourself and your work. So go ahead.
All right. Yeah. Thank you for the introduction. Yeah. So what I'm gonna show is more intended as a spark to spark the discussion regarding large language models and AI and how could it be used in allotrope. You should be able to see my slide right now.
Yes.
Yes.
We're good.
Okay, perfect. So yeah, as already introduced, so I'm a PhD student at the University of Stuttgart. I'm not a chemist, but I work in the field of research data management. And yeah, my main work is this application, web application to edit JSON schemas and do all kind of cool stuff with JSON schemas. Yeah, I assume most of you are familiar with JSON schema, as the allotrope simple model uses JSON schema, right? So it's very much familiar term to most of you.
Yes.
Yes. Okay, perfect. All right. So I'll give one quick overview of my work and then also highlight what might be relevant for allotrope and especially for our discussion. So yeah, so my work is this tool meta configurator. I'll give you a very short demonstration to enable anyone, so domain exports or anyone who might not yet have any programming background, to edit and generate their own schemas or models with graphical visualization and also natural language based editing, which I'm going to show. And then based on these schemas, also users can generate source code. They can generate documentation, they can fill in instances, and so on and so forth. What will be most interesting for you, I guess, is the AI assisted part. Okay, so let's just jump right ahead and go to the tool in a live demonstration. So yeah, what you can see right now is this web application. It is open source, it is fully free. And what we are going to do is we are quickly building one simple schema and then using some AI features. So I brought to you an example case from MOF synthesis in chemistry, where we have existing experiments documented in an Excel table, but it could be also from any other source. We have 15 experiments. They have certain properties. Yeah, I mean, we don't have to know too much about the actual data. So now what we can do is we can import our documents. Right now, what we support is JSON, YAML, XML, and CSV. There are some import options which we can ignore. So we can import it. It was right now converted to JSON, and we also have this graphical view to fill in the, to edit the data or add also new instances of experiments. What already happened in the background is that a schema or data model was generated or inferred from the instance data. And in this, so I now switched on the top to the schema tab, where we can edit our schema. And yeah, in this graphical view, we can edit the schema. For example, our purity was inferred as a string, although we would prefer it to be a Boolean true or false value, because the values are either it is a pure product or not pure. And now let's use our AI assistant to make some more changes to our model. We don't want to bother with the underlying syntax of JSON schema. Okay, so I've opened this AI prompts view and I give it one prompt. In this case, so right now in our data, let's go back to our data shortly. We will see we have our temperature and duration both being fields that contain a value and a unit. It would be more nice to model it separately by having one field for value and one field for the unit. So let's just model it properly. So we can say right now the temperature and duration are text fields with both the value and unit. Please change it to have separate fields for value and unit for each. Okay, now I press this one button, and in the background, our prompt plus additional context of the current schema is sent to a large language model, which then makes the corresponding changes in the schema, which already happened. So now our temperature and duration have become split into value and unit. We could also introduce enumerations for our unit, for example. So we could say, make it an enumeration of reasonable temperature units. And so in this way, someone can make changes to their schema without knowing the underlying JSON schema syntax. So let's open one more view, which is the actual text view where we can see the actual schema. So as you know JSON schema, this is how the document looks like. This is the underlying schema document. Now, what we also have, what might be interesting for you. So I've heard that you have a lot of efforts in mapping data. So you have different instruments, and these instruments produce some kind of data, usually in proprietary formats. And you want then to convert this data to the standard. One idea how this could be solved is an approach, which I'm going to show you, which is you use AI to generate mapping rules and then apply these mapping rules deterministically. So what in my experience, if you use large language models on huge amounts of data, it will start to mess up. So these large language models, for smaller data, I got almost perfect results. But once the data sets are large, it will some stuff will be messed up. And so our approach or thought is, let's give a large language model some relevant context to infer mapping rules, but these rules are then applied deterministically. So let me press this one button to generate such rules. Right now, so what we had was our document, which we see still here in the left. For example, purity has the values yes or no, or we have our temperature and duration still in like value and unit still in the same field, but we have modified our schema. Now we want these changes to be reflected in our data. That's why I press this button to generate mapping rules. And the mapping rules now, in this case, are essentially a new target document using placeholders of the old document. So for example, for temperature, we now have it split into value and unit. Unit is always Celsius, which works because it's in the data always Celsius. And as value, it now uses a substring of the previous temperature value before Celsius. And for purity, it now generated a logical operator to check is it yes, then true, otherwise false. So essentially we generated these mappings using large language models, but now apply them with a deterministic algorithm, which means even if the data is large, it still works. So that's just two demonstrations of what could be done using large language models. And just one very short last slide of how in the background the system could work, or how in our case it works. We have a target schema. So for this automated mapping, we have a target schema, and we have a document which does not yet satisfy the schema. We then take the current instance document, which might be very large, very large, and then we use an algorithm to trim it in a smart way that we still have all the interesting properties, but let's say we have 1,000 experiments, it would be sufficient to have maybe only 5 experiments, because they all have the same structure. So for inferring the mapping rules, we trim our document in a smart way, because we cannot give a large language models our 10,000 experiments. We also infer a schema of our current document to also get more relevant context. And then we give all these documents, so target schema, schema of the source document, subset of the source document, and very detailed instructions on how such a mapping has to look like to a large language model. And yeah, this prompt is then built up like this. So we describe the overall task, we give it also examples, and so on and so forth. And finally, our large language model gives a response, which we post-process, because usually it contains some kind of quotation marks, which is called code fence around the response, which we cut off, and then show our users the mapping result, and the users can still make changes to this mapping. So if some part of the mapping might not be good, that's okay. It is a user in the loop system where the user can still make changes to it, and also sees whether the web mapping is valid in terms of syntax. And finally, the mapping can be applied. So that's how, in this case, the mapping works. So just as an example, what already can be done with AI. And we are also planning to work on integrating ontologies in the tool, and in evaluating and handling more complex scenarios. And unfortunately, right now, we don't support external references, which is very essential for Allotrope. Yeah, I will reach out back to you once we have external references, which actually is in our to-dos right now. Yeah, that's actually what I wanted to show. Hope you found some of it interesting, and let's have a good discussion.
Great. Thank you very much, Felix.